Hello all, we are doing the chapter Quadrilaterals and under it we are studying the properties of a parallelogram. In this lecture we will be stating and proving the theorem number 1. So the theorem number 1 goes like this. A diagonal of a parallelogram divides it into two congruent triangles. We have already seen this property by doing an activity in the previous lecture. Let's prove it here mathematically. Now let ABCD be a parallelogram and AC be its diagonal. Let's get our parallelogram on the screen. Yes. In this parallelogram, the diagonal AC is dividing it into two triangles, namely ABC and CDA, right? Now, if you observe, AD is parallel to BC and AC is a transversal. What I mean by this line is, for the given parallelogram, AD and BC are sides of the triangles as well as they are parallel to each other, wherein the diagonal AC is acting like a transversal. Transversal or the line which crosses two other lines. So what is the conclusion we get from this observation? We note that angle BCA becomes equal to angle DAC by using the property of pair of alternate angles. So let's recall the property. So the pair of alternate angle property states that when two parallel lines are crossed by another line, which we also call a transversal, then the alternate interior angles are equal. What I mean by this statement? That when two parallel lines that are AD and BC are crossed by the transversal, that is AC, the alternate interior angles that are BCA and DAC, as you can see on the screen, become equal, right? Understood? Moving ahead. Now, this is the result we obtained previously. Also, if you observe, AB is parallel to DC too. Because it is a parallelogram, we have both pairs of opposite sides as parallel. And that is why AB is parallel to DC, and here also AC will act as a transversal. As you can see with the yellow marker, using the same property of pair of alternate angles, we can conclude that this and this angle are equal to, that is angle BAC and angle DCA are equal using the same concept we used to prove why these two angles were equal. Alright. So last but not the least, we also observe that AC is equal to CA and I have written a common here. Why have I written common here? It is because both the triangles share a common side AC. Hence, we have mentioned it here as a common side. Now, I think there's nothing more to do about it. We have already proved that these two are congruent triangles. You may ask how. It is because with the help of property ASA, angle side angle, we can say that these two triangles become congruent because they satisfy these three criteria. Let's revisit the property of ASA. The ASA rule states that if two angles and the included side of one triangle are equal to two angles and included side of another triangle, then the triangles are congruent. Alright, so the two angles are BCA and BAC of one triangle and DAC and DCA of the other triangle and one included side, that is AC. Satisfying these three criteria make these two triangles congruent to each other. I hope we have understood how this theorem works and how is it proved. Next, we have a summary for you since you have consumed a lot of knowledge. After satisfying these three criteria, we have finally proved that triangle ABC is congruent to triangle CDA. That's all for the proof for this theorem. We will continue with another proof in the next lecture. Thank you and all the very best.